Hello guys, welcome to the next lecture. This lecture is specifically on Scada. It's a part of Unit 3. So Scada means Supervisory Control and Data Acquisition System. Earlier we discussed about the mm, Programmable Logic Controller, Human Machine Interface. So this Scada is the advanced type of a controller used in the industrial automation. So supervisory control and data acquisition is an industrial computer-based control system used to acquire the real-time data to keep track, monitor, and control industrial equipment at the supervisory level. Okay. So it's a combination of the software and the hardwares. Of course, the hardwares, especially the PLC, programmable logic controllers, and HMI, and internet communication protocols. So we need to um, establish the communication, hardware and software communication between the SCADA and the other controllers. So it is used in different types of industries and various domains. Um, so the purpose of SCADA is to collect the data and control process from a distance. Distance means remotely. Okay. So SCADA can create logs on the system current and past state. Okay. Logs means data logging. Okay. So we can be able to log the current status of particular industrial processes. Okay, and as well as we can store them. Okay, for future reference. Okay, and yeah, SCADA can send necessary information to operators in real time. Okay, using SMS and other internet options. Okay, if we have the Android device in our hand, we can get the real time happenings in industries by using the SCADA software. Okay, so we can monitor the industrial processes remotely from anywhere. Okay, if we have SCADA software and relevant the controllers in our industries. Okay, so the SCADA reduces the manpower needs and it saves the energy, and also of course it saves the time, even the money. Okay, and it reduces the traveling of workers from one station to another station within the industries. Okay, and it is more reliable and supervisory control over a particular system. So the overall function of the SCADA is listed in this slide. Very main and important function of the SCADA is data acquisition and display the data on the screen. Okay, either in the computer or in the HMI screen or in Android devices. Okay, and alarm and events. Okay, so record important changes and operator actions, and if it is required in case of emergency, it gives alarm to the operators. Okay, and history database. So the SCADA is used to keep a record of the process values for particular period of time, so we can refer them whenever we want. Okay, measured processing, of course. So data acquisition system is used to measure the process parameters, for example temperature, pressure, and other parameters like flow rate in case of food processing industries, bottle filling industries. Okay, so we can measure the process parameters and save them. Okay, and logging and reporting also possible. And yeah, Scada uh, will interpret with the human machine interface, even the PLC also. So simply you can say the HMI and the PLCs are the part of SCADA. Okay, so we can display the presentation of particular the operations of industries on the HMI screens. Okay, and also we can be able to display the reports. Okay, either in the form of graphs or in the form of Excel files. Okay, and operator command handling also possible. Okay, so the manager or the boss of the industries can send the commands to the operators via SCADA. So the domains where actually the SCADA uh, is used or nothing but electrical generation. So in power stations, people are using the SCADA, for starting up the power generation or for shutdowning the power generation. It is used for transmission of the electrical power. So the SCADA is used in the power grids. And yeah, SCADA used for industrial automation. Okay, without SCADA, it is not possible for us to automate any industrial operations nowadays. Okay, so the SCADA is used in the railways and other transportation methods. Okay, and the SCADA used in the chemical storage and transportation. So history of SCADA. Before the concept of SCADA, the industrial plants and the remote sites relied on the personnel to manually control and monitor equipment via push buttons and analog dials, like use of electrical push buttons, levers, relays, timers, electrical counters, and etc. And also a lot of wirings uh, are there if you use the conventional type of electrical controls. Okay, so industrial organizations started to utilize the relays and the timers to provide some level of supervisory control without having to send people to remote locations to interact with each device, especially in the hazardous environments. Okay, so the SCADA plays a vital role in the hazardous environment where actually high temperature are generated, and as well as especially in the atomic power stations. So there are four types of SCADA systems. The first generation is nothing but the monolithic or early SCADA system. Was developed in the early stage of 1950s, and it was alive till 1970. And second generation is distributed SCADA systems, was developed in the early stages of 1980s, was used effectively till 1990s. And third generation is network based SCADA systems. Okay, it was developed in 1990s. The people were using this third generation till 2000, 2005. And the fourth generation, the current SCADA system, is nothing but Internet of Things, IoT based SCADA system. So the monolithic early SCADA system or microcomputers based SCADA system. So microcomputers are used earlier for computing the SCADA systems. In earlier times, the common network services were not available. Okay, so hence these are the independent systems without having any connectivity to the other systems. Okay, so there was no any internet kind of connection from the SCADA system to other outside world. Okay, So the function in the early first generation were limited to the monitoring sensors in the system and flagging any operations in case of superposing programmed alarm levels. Okay. Otherwise, change in the operation, change in the sequence of operations. Okay. Introducing the new kind of operations suddenly or changing the program were not possible in these early SCADA systems. And distributed SCADA system, the sharing of control functions is distributed across the multiple systems connected to each other using local area network, that is LAN. Okay, so there will be one supercomputer to monitor everything, and yeah, the control will be distributed to the other computers, which are standalone, act as a standalone system to operate particular machine. Okay, so these individual stations were used to share real-time information for performing control tasks to trip the alarm level of possible problems. The cost and the size of the station were reduced compared to the first level or first generation SCADA systems, as each system of the second generation was responsible for performing a particular task with reduced size and the cost. So, but even in the second generation systems, also network protocol were not standardized. Okay, there was no the standard networking system to connect the SCADA system. SCADA system is the computer which has the SCADA software, okay, with the other controllers and other computers. Okay, so the the difference between the second gen and the third gen, okay, SCADA systems are nothing but first gen and second gen SCADA systems are limited to single site networks called a sealed system. Okay, in these systems we cannot have any risk, okay, compared to the third generation SCADA system, which are connected to the internet. Okay, so if any system is connected to the internet, so there is a chances for the cyber risk. Okay, so there will be a several parallel working distributed SCADA system under a single SCADA architecture. Okay, and networked SCADA system is the latest SCADA system. So that is the current SCADA system, or generally network and communicating using wide area network systems over mobile network, Ethernet, fiber optic connections for transmitting the data between the needs frequently. So we can be able to communicate, okay, the informations, okay, from one supervisory control data acquisition system computer to with other controllers and other computers and the sensors and equipments available in the system from anywhere. Okay, so these SCADA systems are programmable logic controllers for monitoring and adjusting system parameters. Okay, that is uses the PLCs. Okay, so open system architecture and communication protocols. So architecture of the current internet-based SCADA system is depicted in this slide. So generally the SCADA system includes the following components. Okay, local processors, maybe a microprocessor, okay, and operating equipment. Okay, so of course uh, uh, in industries we have the equipment for performing certain operations. Okay, so we need the equipment, we need the controllers. Okay, so programmable logic controllers only the modern controllers actually interact or speak with the equipments. Okay, so none of the controllers like either the SCADA or the HMI cannot speak. Speak means interact with the real time, okay, the physical devices or the equipments available in the industries. So PLC is the must if you want to implement the SCADA for the supervisory control of the entire plant. Okay. Yeah, instruments, definitely we need the instruments because a lot of parameters needs to be monitored, okay, and controlled. So we need the instruments to monitor and control the parameters. And RTU, remote terminal unit, is essential to control any kind of parameters. Okay, and we need intelligent electronic devices. Okay, like yeah, HMI is the one kind of intelligent electronic device. So master terminal unit or host computers and a PC with human machine interface. And yeah, it has different layers, client layer. Even the client can monitor what is happening in this site, okay, in the production site or in manufacturing site or processing site. So there will be a data server layer. Okay, so different layers are there. Okay, so the people who are having the access, okay, to the industries can monitor from anywhere. Okay, so the main components are the SCADA master, HMI, PLC, okay, RTU, and etc. So all these devices should be communicated, okay, properly by means of the physical, okay, communicating wires like Ethernet or Modbus, Profibus, or by means of Wi-Fi, okay, wireless communication. So already we discussed that the hardwares are nothing but we need the sensors to collect the data from the field level. Okay, for example, temperature sensors, pressure sensors, okay, flow sensors, vibration sensors, okay, humidity sensors, okay, etc. etc. Okay, we need the sensors. So all these sensors, okay, will be connected to the a PLC, programmable logic controller. So the sensors cannot be directly connected to the computers. So because these sensors always uh, detect the parameters and produce the outputs in the form of analog signals. Okay, so computer will not accept the analog signals, but they will accept only the digital signals. So we need to use the PLC to get the data from the sensors. Okay, and here and the PLCs will be connected to the computer by means of the proper network. Okay, and yeah, of course, we need to save the data, okay, and process the data, okay, using the computer available in the industries, and then we can monitor them, okay, using the SCADA systems from anywhere. Okay, if we want, we can change the modification in the processes. So this is the architecture of the SCADA software. Okay, so as usual, the PLC, HMI are the part of the SCADA system. Okay, so it consists of the different layers, client layer, okay, and yeah, field layer, supervisor layer, and etc. So the block diagram of SCADA system, okay, is nothing but we already discussed these things. So SCADA consists of PLC, it consists of HMI, it consists of software for programming, it consists of remote terminal unit for sensing, controlling the devices. We have the supervisory systems, and of course we need the communication interface, okay, to connect the SCADA with the other controllers and the equipments. So human machine interface is the part of a SCADA system. So we already discussed the basics of HMI. So it's nothing but a GUI, graphical user interface. So we can create the graphical, okay, the buttons or display units on the HMI screens, and we can operate them. Okay, so HMI is the part of SCADA. Okay, so it is used by linking to the SCADA system software programs for providing the information, including the scheduled maintenance procedures, detailed schematics of the particular operations, the trending, so what is happening, okay, in the industries, and diagnosing the data for specific specific sensor or the machine. So HMI system facilitates the operating personnel to see the informations graphically. Okay, graphically. And if you integrate the HMI with the Scada system, okay, we can process the data and we can take the decision, okay, based on the output, okay, given by the Scada system. So supervisory control, so supervisory system is used as a server for communicating between the equipment of the SCADA system, such as remote terminal units, PLCs, and sensors, etc. And the HMI software used in the control room workstations. Okay. So master station comprises a single PC in a smaller SCADA systems, and in case of large SCADA system, it comprises distributed software applications. Okay, disaster recovery sites and multiple servers. Okay. Okay. So SCADA system, okay, used for remote monitoring, okay, and as well as it is used to produce the graph, okay, so that we can be able to see the okay the variations in the parameters, okay, through the graphs, okay, and also we can be able to see the different data, okay, trending of the data. So remote terminal units. So far we discussed the HMI. Okay, next one is the remote terminal units. So physical objects in the SCADA systems are interface with the microprocessor controlled electronic devices called remote terminal units. Okay, these units are used to transmit so telemetry data to this SCADA system and receives the message from the master system for controlling the connected objects. So which consists of data logging systems, alarm handling systems, as the field devices for informations. Okay, these remote terminal units can control the IEDs, that is intelligent electronic device, and yeah, it's a slave or master device. So next one is the PLC. As I said, we cannot use the HMI or the SCADA system, okay, for controlling the physical devices or okay equipments or even the sensors. Okay, we need the PLC, okay, to interconnect the SCADA and HMI with the physical devices and instruments. Okay, so in SCADA systems, PLCs are connected to the sensors for collecting the sensor output signals in order to convert the sensor signals into digital data. So PLCs are used instead of RTUs because of the advantages of PLCs like flexibility, configuration, versatility, and affordability compared to the okay RTUs, okay, remote terminal units. So communication infrastructure, generally the combination of radio and direct wired connections is used for SCADA system. But in case of large system like a power station and a railway, wireless network are frequently used. Okay, so we use the private network or internet or wireless communication systems. Okay, to connect the SCADA system with the okay the distributed control systems like PLCs and HMI. The communication protocols are the okay Modbus, okay DNP, field bus, okay controller area network based communication system, floppy bus, direct net, okay, okay, Ethernet, TCP, IP. So these direct net TCP slash IP are especially used for the okay Ethernet and as well as Wi-Fi communication. Okay, so SCADA server, okay, it can be a web server, okay, and yeah, it consists of data logging, okay, it can be able to analyze the data, Okay, it serves the clients through the firewall, clients connected through the internet, okay, real-time decision maker, and as the RTU for the information. So SCADA interact with the, okay, the RTU and the PLC HMI for getting the data. And it analyzes the data and it produces the trend of the data on the screen so that the client can able to visualize, operator also can able to visualize, okay, the manager can also can able to visualize and take the decision. So SCADA programming is the very important part of the SCADA system. We need to program, okay, to develop the GUI, okay, graphical user interface. Okay, so the SCADA programming in a master or HMI is used for creating the graphs and the diagrams which will give an important situational information in case of an event failure or process failure. Okay, so we'll be doing the SCADA programming in the, okay, the laboratory session. Okay, so mainly the SCADA and HMI are nothing but creating the GUI, that is for representing the, that is graphical representation of the buttons, okay, display units, alarms, and yeah, if you want, you can develop the graphical representation of certain, okay, components like a tank. If you want to monitor the water level in the tank, and we can be able to graphically represent the bottles. Okay, in case of bottle filling, we can, okay, develop the graphical representation of the bottles and etc. So the SCADA programming can be done using derived programming language or C language. Mostly the programming, SCADA programming is user friendly, but the thing is we need to practice. Okay, so event and alarm is the main part of the SCADA. So alarm is an indication of an undesirable condition of particular environment, okay, detected by the some sensors and devices that is not responding to input commands. The alarm alerts operators that is condition needs to be fixed. Otherwise, it is going to be the, okay, dangerous for the, okay, people who are working in that environment. Event is a detectable occurrence which is of a significance to the change of the SCADA. Okay, so recorded changes can be of the three kinds: informative, no action required. Okay, warning, plant could stop or be damaged if no corrective action is taken. Blocking, the controller took action to protect the plant and further operated prevent until the reason is, okay, clear. Okay. So monitoring and event processing of the SCADA. Okay, okay. So will be monitor uh, uh, the process parameters. Okay, we can see the, okay, upper metering limit, okay, upper alarm limit, upper, okay, warning limit. Okay, based on the working conditions and the type of operations. So either the SCADA system will take the decision by its own, or the person is, okay, person wants to take the sudden decision based on the condition, he can take using the SCADA system to change the working conditions or to stop or to pause the operations. So alarm logging, okay, is alarm logging provides the straightforward process for creating and maintaining records to analyze the alarm state of equipment and processes, okay, in our system. Okay, so we have come to the last part of the SCADA system. So in conclusion, SCADA is a control system with more front end functionality. Okay, so more interfaces and efficient storage. Okay, more uh, storage of data. Okay, and more record or device oriented configuration, but system wide configuration tools are needed. So less expensive compared to distributed control system, but offer different functionality. okay, compared to DCS, and finally various applications. So in our next lecture, okay, we will be discussing about the DCS, and also we'll discuss how the SCADA system differ from the DCS.